In today's video, we are going to move on to division properties of exponents. So we have two rules here that deal with division. And so you're very likely going to see, excuse me, fractions, because remember, fractions are just another way to write a division problem. Okay, rule number 1, quotient of a powers rule. So quotient is the word that describes division. This rule says for every non-zero number a, so just say you have a number, and integers m and n, to divide powers with like bases, you're going to subtract the exponents. Okay, so before I write that out, let me give you an example. So let's say we have x to the 5th divided by x to the 2nd. Okay, so we have to have the same base. They both have to be x. So if I expanded it out, there are 5 x's on the top. There are 2 on the bottom. And so let's start to divide. So this x divided by this x cancels out to be 1. This x divided by this x cancels out to be 1. Well, how many are left? Well, there are 3 left. So I want you to notice that 5 minus 2 gives me 3. Okay, so the rule is I'm going to take a and I'm going to take the top exponent minus the bottom. That's how I'm going to simplify it. Now the reason we do that is because think about canceling. If there are 5 on the top in my example over here, if there are 5 on the top, 2 on the bottom. So the 2 on the bottom will wipe out 2 on the top and we're left with 3. So that's where our x to the 3rd came from. Okay, this next rule, in my opinion, is really not that much different than the rule from the prior day, raising a quotient to a power rule. So when you've got for every non-zero number a and b, you have different numbers and you have parentheses, it's all raised to the n. So we're still going to apply the power into the parentheses. So I'm simply going to rewrite this as a to the n over b to the n, and that's it. If I can do more simplifying, I will. Okay, let's do these rules and then bring in other rules we have studied. All right, b to the 4th over b to the 9th. Step 1, let's just work through the rule first. All right, so that would be b to the power of top power minus bottom. So 4 minus 9 is negative 5. And so I can't leave a negative power, so I have to do the reciprocal. So the answer is 1 over b to the 5th. Now let me go to the top and expand it out. Let's say we wrote it out. I've got 4 in the numerator, b to the 4th. And I got to write out 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, let's start canceling. These 2 wipe each other out. Those are gone. Those are gone. Those are gone. So it looks like nothing is left on the top, but it's really a 1. Look how many are left on the bottom. 1, 2, 3, 4, 5. Okay, so take a look at what we got down here. 1 over b to the 5th. Okay, so think of it like a canceling method, or we're going to subtract powers. Okay, number 2. I'm going to take z, they're both the same, to the power of 10 minus 5. Well, 10 minus 5 is 5. So my answer here, z to the 5th. All right, number 3. Okay, again, even though they're all right next to each other, remember, this is just multiplication. 8 times m to the negative 1 times n. And then all of that divided by 2 times m to the 3rd times n. Now, I want to group together things that are alike. So here's one way to do this. Let's kind of write different fractions. I'm going to keep the numbers in a fraction, 8 over 2, times, let's put the m's in a fraction, m to the negative 1 over m to the 3, and then the n's, n squared over n. So now let's just simplify them. Well, the first one says 8 divided by 2. Well, I know 8 divided by 2 is 4. All right, the second one, what I'm really doing, I'm going to jump up here. I'm doing m to the power of top exponent minus bottom. So -1 minus 3 is -4. All right, so I'm going to jump back down here. I'm going to have times m to the -4. And then the ends. N to the power of top exponent minus bottom. Remember, there's a 1 there. So 2 minus 1 is just n to the first, or n. So bringing down here to our problem. So I'm almost done. It's just this right here. I can't leave a negative power. So I only need to take the reciprocal of that part. So what that means, if it helps you to see them all over 1, I'm going to leave the 4 and the n exactly where it's sitting. And then I'm going to flip over the middle fraction. And when I do that, I can make that power positive. So that would be m to the +4th. And there's our solution. Okay? So I chose to write it out separately. You also could kind of do this. Let me get a different color here. You also could kind of say, all right, I'm going to group together the 8s. I'm going to group together the m's and the n's. Okay, so it's kind of hard. It kind of makes the picture messy there, but that's another way to do that. All right, if you want to stop the video here and try some, go ahead, but I will keep going through examples with you. Okay, on the next one, I'm going to kind of do what I said a second ago. I'm just going to kind of separate. I'm going to look at just the x's, just the y's, and just the z's. All right, I have x to the power of 2 over x to the power of 1. So I'm going to do top exponent minus bottom. So I'm going to just do a couple notes over here. Top exponent minus bottom. Okay, so that's going to be x to the first power. Okay, so I'm just going to bring x down here. Second one, I'm going to take y. Top exponent minus bottom. So -1 minus 4 is a -5. So now I have y to the -5th. And then over here to the side, I'm going to take z. Top exponent minus bottom exponent. And so do you see how I have 4 minus -3, not just 4 minus 3? So 4 minus -3 is actually 7, because I can simplify out. You know, I can go like this. These become positive. So coming down here to my problem, I have z to the 7th. The only thing I need to adjust is the y. So I'm going to have x and z stay in the numerator. I'm going to take the reciprocal of y, and it will change the 5 to a positive. So I have x times z to the 7th over y to the 5th. Okay, number 5. Multiple ways to do this. One way is to get the power on the outside into your parentheses. So raise 2 to the 3rd, x to the 3rd, 5 to the 3rd, x to the 3rd. So if I did that, 2 to the 3rd will be x to the 9th. I need to multiply powers. I have to do 5 to the 3rd. And then x to the 4th to the 3rd, multiply powers, we get 12. So 2 to the 3rd. 2 times 2 is 4. 4 times 2 is 8. 5 to the 3rd. 5 and 5 is 25. Times another 5 is 125. Now, does 8 over 125 reduce? And it does not. But I do want to look at the x's. So I'm going to go ahead and start my problem. I'm going to go like this. I know I'm going to have 8 over 125. So I need to figure out, I have x to the top exponent minus bottom. Okay, so that gives me x to the -3rd. So I really, when I do that, it's really sitting in the numerator. But it's still negative. So now I need to take the reciprocal of just the x expression, just this. So when we do the reciprocal, it's going to end up flipping down to the bottom. So my final answer here is going to be just 8 in the numerator, and then the denominator is going to be 125 x to the 3rd. Okay. Now, we also could have started by simplifying x to the 3rd over x to the 4th. I could have subtracted those out and started there. but it doesn't really matter. I guess it just takes a while for you to figure out what works for you. Okay, let's keep going. Number 6. Now, one of two ways. I could distribute or apply the power in there, okay? Or I could do what we did day 1, where all of this is raised to the negative, so let's flip it over. When I do that, it'll make my power positive. So now I can go ahead and apply power 2 into our parentheses. So then I would have 9 to the second over 5 to the second. And then now simplify. That would be an 81 over 25. And I don't want decimals, so I'm just going to leave it as a fraction, 81 over 25. Okay, we have 2 more. So I do want you to pause the video. Let's see what you can do on these next 2. Okay, on number 7, I'm going to do number 7 a little differently than I did number 5. So number 5, I started by taking the outside power and applying it inside the parentheses, which is perfectly fine. But what I'm going to do is I'm going to temporarily ignore the 5, and I'm going to simplify what I see in the parentheses. So here's what I see. I see 10 divided by 2 is 5. I see c to the third divided by c to the first. So when I subtract those 2 powers, I get a positive 2. I see d squared over d to the, oh no, I'm sorry, those are different. So let me take that back. D squared is going to have to stay here. E to the 8th is going to have to stay there. Okay, I was going to combine those and I cannot. All right, so now let's bring back in the 5. Oops. Now let's get the outside 5 to all components. I need to take 5 to the 5th, raise up C, raise up D, raise up E. All right, 5 to the 5th. I'm going to grab my calculator. 5 raised to the 5th is 3,125. Now, when I raise all these other powers, I'm multiplying. So if I have C to the 2nd and I raise it to the 5th, I have C to the 10th. D to the 2nd raised up to 5th, so that's going to be D to the 10th. And then same thing on the bottom, E to the 8th raised up to the 5th, 40. Now, I could have began by taking the 5 and applying it to the 10, the C, the D, and then the 2, the C, and the E. I would have still ended up with my answer I have circled. So it doesn't really matter which way you begin. And so you might try a couple methods and see if maybe, one way makes a little bit more sense than the other. All right, let me show you another way to do this one. So instead of doing what I did earlier, which there's nothing wrong with what we did right here on 6, the entire thing is raised to the same power, so you can flip the whole thing over. So if you don't want to do that, you can go ahead and apply the power into the parentheses. So that would give me a 7 to the negative 2nd, a to the negative 2nd, and then on the bottom I have m to the negative 2nd. Now, I'm going to still do the same thing I did before, where I'm thinking about reciprocaling everywhere. So the 7 has to go down, the a goes down, and the m ends up coming up. So I end up having m squared on the top becomes positive. The 7 goes down to the bottom and changes that to positive 2. The a reciprocals down to the bottom and becomes positive. And then I can't leave it as 7 squared. So let's go ahead and multiply that and get 49. So my simplified answer, m squared over 49, a squared. Okay, so I think we probably picked up almost every property or every rule, except I don't know that we worked with the 0 power on any of these, but I think we captured all the others. Okay,